Hello everyone. Good afternoon from Brisbane. Can you hear me? Okay, thank you. Okay, so I think we have cost two minutes, so we can start. I think so. Today we are going to talk about generative AI for information extraction. Especially, we will see how we can use the ideas we have learned, like GAN's language model, uh, and how we can combine them together or use them individually to extract information from unstructured data. So I described my biography yesterday. I can skip this slide, I think, for today. This is our team, as I said, and again the disclaimer that any slides that we provide during this session that needs explicit. If you want to use them or like reproduce them, you need explicit permission from Professor Rechinayak or the individual author. Okay, so to go to our specific idea of extracting information through generative AI, let's have a little bit of basic understanding about AI and how those generative AI sits inside the AI technologies, and that will give us a little bit of high-level picture of overall things. I think the presentation slide is already shared. Uh, in in case of volume, let me try if I can increase the volume. Volume. Uh, okay. I don't think I can increase the volume. Let me stop this sharing first to see if I can increase the volume. Okay. Uh, I don't think I can do anything about the volume. Can you hear me a bit better now? Okay, that's good. Yeah, thank you. Okay, so let me share again. Share this screen and then presentation. Okay. Now I need to run that thing again. It's a little bit funny. Okay, so to discuss about AI, so let's try to understand the AI thing from a very layman terms instead of going very technical and formal definition of AI. So by AI, we understand that it is the mechanism where a computer system can simulate human intelligence. For example, how human makes decision, understand things, and so on. So there are several key concepts in this AI area that are very relevant to what we are going to discuss today. Uh, the main two concepts would be machine learning and deep learning. So the machine learning refers to a subset of technologies, algorithms, and procedures that are inside the AI domain, but they can learn from data, right, to predict human intelligence or predict about future based on the data they saw in the past. On the other hand, when we use deep learning models, they are spatial or subset of machine learning algorithms that uses neural networks, layers of neural networks to represent data and make prediction about the data. And we can see AI is being used in everywhere nowadays. And Andrew Ng, he suggested that there will be a time when AI will be something similar to electricity. Like electricity are being used in everywhere, in every aspect of life, and it is blended in our life in a way that we don't realize that we are using electricity. Same thing will happen for AI, and we are already seeing that it is being very commonly using in different areas and industries and research everywhere. So, for example, in healthcare, we use AI to diagnose diseases and personalized medicines and so on. We use in finance to detect fraud and trading patterns that can help us to make better decision in trading. In transportation, we see that autonomous vehicles are already running on our roads. We use AI for traffic management and so on. So, so in the AI, as I said, we are going to use generative AI models, right? So we need to understand what is the difference between this generative AI and then another thing is called discriminative AI. Having a clear idea will help us to decide what kind of models and techniques we should use in different applications and data, given data, right? So let's start with the traditional techniques. So in the traditional domain area, like in symbolic AI and so on, people used to define some rules, and then for each instance, or say in financial transactions, they given a transaction, they compare that the transaction against the defined rules, and based on those rules, they decide whether a given transaction is fraud or not. So that means it was tedious. People need to carefully observe the data patterns and then define those rules, and that will help us to detect those fraud and other classification things. Then there came the machine learning machine learning idea where people train machine learning algorithms that can learn from data. So instead of defining those rules, people provide instances, for example, transactions and their corresponding labels, that is whether it is a fraud or not. And the machine learning algorithms will learn those rules from these observations like transactions and their labels and come up with rules that they will use those rules when new data comes in to decide whether a transaction is fraud or not. So this helps significantly to reduce burden from people to find out all those patterns, and also when machine finds patterns, they can find more complex and very from various, they can analyze data from various perspectives and come up with much more complex rules that can give us more accurate prediction rather than people finding out those rules. For audio purpose, what if I remove this one? Let me try the audio in it. Can you hear me better now? So I removed my headphone. Okay. So okay, let me yeah, remove the headphone. I think something with my headphone. Okay, very good. So you can see in these machine learning techniques, these are called discriminative machine learning techniques. So where given instances, we have classes, say two classes, for example. Then here, the first one you can see, if we think that we need to decide given some instances of pictures, and then we need to decide whether it is a cat or dog, then our discriminative algorithm will try to find out a line or plane or hyperplane that can separate between these cats and dogs. And using this line, if a new instance comes in and then it tries to decide whether it sits, if it is on the left top side, then it is a cat, and if it is in the like right side, then it is a dog, right? So this kind of models, they try to find out a boundary. In this kind of models, you try to find out a boundary that can separate between instances, and you use that boundary to decide your classes, to decide whether it is a fraudulent transaction, it is a dog or cat, and those kind of things, right? So in these kind of models, let me use my pointer. uh, yeah. So in these kind of models, we try to directly estimate the probability of a label or class given the instance. So given this picture, we try to estimate what is the probability that this one is a dog. Or given this picture, we want to estimate what is the probability that this one is a cat, right? So this is, and that's why you can see here we are trying directly mapping. We are trying to find out a function that can directly map a given instance to a class. So that's why this kind of modeling is a little bit simpler when you compare with generative models. So on the other hand, if you are using generative models, they try to find out the joint distribution between your class and the label. So it is more like this. You want to find out what is the joint probability of your label or class and your instance X, right? So we want to find out this joint probability distribution. So how do we do that? Finding the joint probability is much more complex. You need like a more complex model, more data to like explore the whole distribution, whole joint distribution. So how to do that? Usually what we do is we try to generate data, like given a class, say y, for example, this cat class. So given a cat class, we try to generate data, and then that will maximize the probability that the generated data is a cat, or generated data lies in that class, right? So we use that technique to model this conditional probability. So instead of predicting the class from the data, here given the class, we try to generate the data from the class. So, and then if we know what is the probability of the data given the label, then we can use Bayesian theorem or Bayes rule to find out the probability of the class from the data, right? So you can do that. So you can see this one learns more complex and more rigorous distribution, and that's why uh, that model is complex, requires more data. And but if you can learn the joint probability distribution accurately, this can give you more natural prediction, right? So and it becomes more general, or you can use it for many diverse tasks. So let's see how AI actually started, right? So if you see into the how AI started in the early beginning, and there was AI winter, right? So the early beginning, we can separate it into two eras. One is 1950s to 1960s. So during this time, Alan Turing,
he proposed Turing test to see whether a machine can exhibit human intelligence, right? So this was a remarkable thing during the time, and people thought maybe machine would never be able to pass this Turing test. But yeah, fortunately, no, actually, Turing test was broken, and then yeah, machine can now do the human intelligence simulation. Then came this John McCarthy. He coined this term, artificial intelligence, in 1956 in a conference called Dartmouth Conference. Right. So from that time, people started to use this terminology and work towards this idea of artificial intelligence. And then came these two remarkable computer programs. One is logistic theorist. This is called the first computer programs that can simulate, or that was developed towards artificial intelligence. And then another one was general problem solver. So general problem solver was more visioned as to be more general purpose than the logic theorist program, right? And then the next era is 1970s to 1980s. During this time, expert system came. So in expert system, there are multiple programs, and then they were like designed in systems that can make human-like decision for specific domains, right? So during that time, people were very excited that they are going to achieve some sort of artificial intelligence that are useful in real world applications. During this time, the people mostly used the symbolic AI. That means all the rules will be defined as different symbols and reasoning mechanism to decide to make the decision, right? And so during this time, people were very excited that they will get something, right? But what happened is there were not enough computation power and not enough data to train those models. So that's why it is the people got frustrated. Some people thought, okay, we are not going to achieve this one, right? And then there were additionally there were some fund cards, and then there was less interest and investment towards AI research. And then so this one is from 1974 to 1980. This is like first winter of AI. People, like you can see here, people started to like move into another research areas. And then the second winter is 1987 to 1993. Um, so during this time, people got more frustrated because of there were many economic uh, problems. So there were economic factors that impacted the AI research, and then people further abandoned AI research. So after that, you can see uh, uh, from 1990s to present, this is called modern AI era, and then there were significant AI progress there during this time. So in 1990s, machine learning, people moved from symbolic AI to machine learning. So in symbolic AI, you need to define all the rules using symbols, and then a reasoning mechanism to make the decision. People found that that is very tedious and may not meet the AI goal if they go in that way. So some people came up with the idea that they should use machine learning rather than defining those rules. So people moved to machine learning, and during this time, support vector machine was very popular. And then that achieved like in some areas, it achieved significant accuracy for making the classification prediction. And then came to 2000. After 2000, there was a big data revolution. So there were more storage capacity and a bit of more computational power to run big algorithms. And during this time, there was another significant shift towards machine learning that is called deep learning. So in the deep learning, people use neural networks, layers of neural networks to learn data more accurately and learn more complex and bigger data set. And then they make prediction that became more accurate than those trained on a smaller data set. So after that, if you say from 2010 to present, there has been remarkable advancement in AI, and that's why now people are using AI in everywhere. During this time, I will say there were three significant things that revolutionized the AI area in the industry, or that brought AI to common people. So one is the GAN model. So then the GAN model was very successful and in generating realistic data like face, deepfake, and those things, right? So people saw that as like very astonishing, very interesting that machine can generate very realistic photo images or videos and deepfake, right? Those things, and people got interested, excited about AI. But that happened mainly in image domain. The problem was that in the image domain, they were using like convolutional neural network or feed-forward neural network. Those kind of things were good for image, but they are not very successful for text or like other sequential data. In the text data, people used to use recurrent neural network. The problem with recurrent neural network was it was very slow. All right, the training that took much longer time than training a CNN or feed-forward neural network. So that was actually hindering the success of AI in the text area. And then in 2017, there was a paper called Attention is All You Need. So in that paper, they explained that if you use attention mechanism, you can actually learn long-term dependency between the words in a sequence, or like in sequential data, words in different time stamps. So during this time, Transformer was born, and then people started to use Transformer for many different tasks. And that actually led to the development of large language models, for example, BERT, GPT, ChatGPT, and so on. So we can see that there are some key milestones here. In 1997, IBM's Deep Blue. So Deep Blue was a artificial intelligence model that actually defeated world chess champion Gary Kasparov. And then in 2011, IBM's Watson wins Jeopardy against human champions. That got lots of media attention. People from that time, actually, people got very excited about AI, and then industry people, they moved towards AI after this milestone. And in 2016, Google's AlphaGo defeated Go champion Lee Sedol. So after this 2016 milestone, people were like, especially scientific people in scientific domain, they were very hopeful about AI, and then they started to imagine that AI will lead us to a very successful successful domain. So, and then in 2020, starting from 2020, there was enormous advancement in AI applications, and various industries, they started to adapt AI technologies. Okay, so let's do some quiz. What we have solved so far. So for this one, it says, what is artificial intelligence? Um, Okay. Yeah. So the first option is the ability of a computer to perform tasks that require human intelligence. Looks like this one is correct. The study of living organisms. That is not like AI. We can study living organism using AI, but that is not just purpose of AI. AI is more general, right? The process of creating new software. You can create new software with many different ways, not necessarily on AI. So that is not correct. The use of computers to solve mathematical problems. Yeah, again, this is very a specific example, like application of AI. It is not the holistic AI. So A is the correct answer. Second quiz, what is the primary focus of generative model? So I think so generative model, modeling the joint probability distribution of your data and the label. Looks like correct. Then B says modeling the conditional probability. Conditional probability is for discriminative model. Minimizing the classification error, that can be for any model. Maximizing the margin between classes, that is discriminative model. So looks like A is the correct one. And yeah, most of the people said A, which is correct. So, and then this quiz, what key event in 1956 is considered the birth of artificial intelligence as a field of study? Looks like we have mixed opinion about this one. Let's see. So the first one says the invention of Turing machine. So the invention of Turing machine was important. Um, right? But that was not the key event that gave the birth of artificial intelligence. To make it a little bit more clear, the question, uh, this one is actually talking about when did the artificial intelligence terminology came in, right? So that came in when the terminology was coined, right? So coined in a conference. The conference name was Dartmouth conference. So during this conference, this concept of artificial intelligence came in. And after this conference, during this conference, there were like discussion and things. People started to talk about these things, and then AI revolution happened after. Like starting from that, AI, actually not revolution, AI started significantly after that conference. The development of first neural network, that was not the start of AI. That was like towards the end of, not end, like towards the revelation of AI, not the beginning. The creation of first computer, that is not AI thing. First computer was created much earlier. Okay, which AI system defeated the world chess champion Gary Kasparov in 1997? Uh, So chess champion, right? So AlphaGo was related to Go champion. Watson was related to Jeopardy. GPT-3 not. So looks like Deep Blue, right? Yeah. Now let's focus on what we want to achieve today. So we are going to use GAN and language model for information extraction, and we will try to like use them separately, like we will see how we can use language model for information extraction, and then we will see how we can add the language model with GAN model to make a better information extraction. Let's see what is information extraction, right? So in the information extraction, the idea is given a source of unstructured data, we want to extract structured information from the unstructured data. So that is the goal. For example, given this text, right? So you have given this text in meteorology, precipitation is any product of the uh, condensation of atmospheric water vapor that falls under gravity, right? So this is like text, and then you can ask what causes precipitation precipitation to fall, right? So that is your question, and then the machine will find out that gravity is the cause, right? So that is the extracted information. So this can be one way, like you ask a question and then it gives you the answer uh, for that corresponding question based on your unstructured data source. Another could be given a text, you try to identify the entities. For example, in December 1903, so this December 1903, that is a date, so the entity type is date. The Royal Swedish Academy of Science, which is like an organization, and then awarded Mary. Mary is a person, Perry Curie is another person, along with Henry uh, Becquerel, which is another person, the Nobel Prize in Physics. So this one is a work of art, right? So you can find out all these entities given a text sequence. So that is called entity recognition. You can further find out the entities and their relationship. For example, Steve Jobs was born in San Francisco on 24th of February 1955. So here the Steve Jobs is a person you can identify, and then San Francisco is a place, and then the relationship between Steve Jobs and San Francisco is Steve Jobs was born in San Francisco, so the relationship is born in, right? So that is the relationship, and then the relationship between Steve Jobs and 24th of February 1955 will be born on. So this is the relationship. So you can find out the entity relationship as well. Another thing could be given a text, you can find out the summary from the text. So that could be another thing. Or given an image, you want to find out. So given a scenery, you want to find out all the animals in that image, or maybe all the cars in that image. Some other information, for example, someone is driving a car, right? So those kind of information you can extract through information extraction. Or from an audio clip, you can find out the specific information. So even though you can use information extraction for image, video, audio, text, time series, and many other ways, we will explain this idea in a simpler manner, through text examples, right? So that we understand it a little bit in a more easier way instead of going through all the things. Right? So to find out the to extract the information, there are several techniques. So one is rule-based method. So in the rule-based method, what you can do is you can define some rules. For example, you can use a regular expression, right, to find out specific information. So for example, you can write a regular expression or regex to find out all the dates in a text. So text will be like this one number, and then this is specific pattern, right? So you can find like define a pattern through the regex and find out all the days. The problem with role-based method would be that defining the rule, obviously that is tedious. Sometimes you cannot figure out all the possible rules, right? You see some of the data and maybe come out with 10 rules, and the next day there is some another piece of data and they need another rule and another rule, so that becomes very complex. And sometimes the data and the relationship is so complex that just using some rules cannot actually find out that specific information, right? Especially if the pattern is non-linear, then it is very difficult to define a rule to find out that information. So people started to use machine learning to overcome that barrier. So in the machine learning, you define, you give some instances and corresponding labels. So for example, given a sentence and you label all the entities, and then you ask the machine to learn from that and give you the entities. Or given a text and then the question answer pair, and then you ask the machine to learn about question answers, and then when you ask a new question, then machine knows how to answer that one. And then there is hybrid method, obviously, that try to utilize both of the world, because you maybe you do not have enough label data, so you have some label data and you know some of the rules, so you combine both of them together to utilize both advantages. So yeah, so those are like hybrid methods. And then how it can help us in decision making. So for example, if you have unlabeled data, for example, text, audio, videos, and so on, then by extracting specific information, it can help you to make better decision. For example, organization can look into specific information that can help you to boost their sales and so on, or maybe make better management. And this kind of models can give you better accuracy compared with if you ask people, because finding complex pattern is difficult and people can make mistake. So you can reduce human error if you use machine learning based information extraction. And the thing is, if you ask people to extract information, they will need to go through all these volumes of documents to find out that information, and that will take a lot of time. But if you use machine learning, obviously, it will be much faster. So your decision making will be faster as well. We can see there are many applications of information extraction. For example, in healthcare, you can use information extraction to find out specific information from medical records to make better diagnosis and treatment plans. You can use information extraction in finance to analyze financial reports and news articles to help you find out the trends and associated risk. And you can use it for legal documents to find out relevant information that can help you to analyze your case better. And it can also help actually to improve accuracy of other machine learning models. For example, if you have, you can use information extraction to extract information to train or improve the accuracy of your machine learning model. You can use information extraction for various natural language processing tasks. For example, information extraction is commonly helping chatbots and visual assistants kind of models. And because information extraction can find out entities and their relationships in a very efficient and accurate way, you can use that to build knowledge graphs or ontologies that can help you to inform domain knowledge to during the decision making. Okay, so there is another quiz again. What is the primary goal of information extraction? Okay, let's see. Most of the people saying B. The primary goal, so option A, to generate new data points. So that cannot be true because we are not generating new data. We are trying to extract existing information, right? Not new data. So that is not correct. To extract structured information from unstructured data, looks like that one is correct because we have lots of unstructured data, and then we want to find out that is specific information. So that looks like correct. To classify data into predefined categories, that is like classification, not information extraction. And then D says to compress data for storage. No, that is not correct. So B is the correct one. So let's see how we can use like so our goal will be combining GAN and language model for information extraction. So to do that, let's review some of the ideas that we already learned, like the idea of GAN and idea of language model. And then based on that, we'll try to focus on the specific part of the GAN and language model that will help us during the information extraction. And also just it will refresh what we have learned from other modules. So we saw that one interesting thing about okay, yeah. So about GAN was that it has two models, the generator G and the discriminator D, right? So generator try to learn the general distribution from your data set, and then the discriminator try to differentiate between generated data and the real data, right? So that means to distinguish between general data and real data, the discriminator need to know how the real data looks like. What are the patterns and all the like language structure, if it is takes all the variation and so on. It needs to know that thing. If it knows all the things, then it can differentiate between real and fake, right? So that helps the model. This setting helps the discriminator to learn rigorously about variations of patterns in the data set. So, and because it doesn't need labeling, you just getting unlabeled data is very easy. You just gather lots of unlabeled data, that's it, and then you can train a GAN model. So using this vast amount of unlabeled data, you can precisely learn the distribution of the data. So that is one thing that will help us to utilize GAN model for information extraction. So how we'll do that? Let me give a very basic idea first. So what because now in the GAN setting, the discriminator knows all the variation of patterns in the domain. So now if you have a small subset of label data, then if you ask your discriminator to do the classification for that label data, or learn the classification from the label data, then it already knows all the variation in the patterns and knows how to utilize those variation to make the classification. So that's how it can make better prediction or give you a better accuracy. In other words, in the GAN setting, it can help you to utilize your unlabeled data, vast amount of unlabeled data, and then the label data part that is scarce, and then you usually have a very small set of label data, right? So that's how it can utilize both labeled and unlabeled data. Okay, so you already know from yesterday that when you train the GAN, you have discriminator and the generator, and then when you start, the discriminator loss and generator loss will be different and maybe high, and then the discriminator and generator starts to reduce their loss, and then after a certain point they reach a point where they become quite stable. In that point, we say that the model is trained, or model has learned the required distribution. And then after that, if you want to use it for data generation, you use the generator part of the model. If you want to use it for classification, you can use the discriminator part of the model, right? So that's how we utilize GAN models for different applications. And you already know the steps, how it learns. It starts with some random noise, try to go to some some like learning specific patterns, and then produce the realistic data. And then if you change your random space of z, then you can get different data distribution, and then it produces different real samples. We know the challenges that it could have happen, model collapse, and how to solve that, training instability, and how to solve that thing. We already know that. Okay, so let's say we review this, how we can use like applications of GANs in information extraction, right? So one somehow this one is not saved. Anyway, so yeah, so there was another option actually. So here actually, anyway. So one option is you can use the GAN model to generate new data points, and then that new data points you can use to augment your to train your information extraction model, right? That is one way. Another way, as we discussed, that you can use the GAN to learn a manifold that knows about the variations in the data distribution, that can help you, like the discriminator part, that can help you to make a better prediction. So the benefit would be it improves the model performance, and then it can overcome the data scarcity, either through making the new data points, or like helping in the manifold, like the latent space, better latent space. Okay, so there are like in the application of GANs, there are these things like as I said, it helps you to generate new data points, right? So synthetic data points that can help data augmentation, and it can help you to make the variations through data augmentation, or through learning the variations in the manifold or latent space, right? So that is the advantage. um, Another thing could be in some areas like medical domain or financial domain, it would be difficult to release the original data, but you can train a GAN model that knows the latent distribution in the from the domain, and then people can release that, and then using that pre-trained part of the model, you can fine-tune your model, and then you can get better accuracy. So how information extraction is different from feature extraction. Okay, so feature extraction has different definitions. For example, feature extraction could be given a sentence, you remove all the stop words, right? And then non-relevant information from that, and then you only use the significant words. So for example, maybe high frequent words, or maybe words that are more relevant to classification, right? So you extract those features, and then you feed that feature to machine learning or other prediction model that utilizes those features for making the prediction. So that is like feature extraction. You extract specific features from the instance that can help you to make the prediction. So that is like feature extraction. And then in information extraction, it is not dealing features. So it is like extracting the information, so that information that is useful for human or maybe other models as well, to make the better decision, right? So for example, here we want to know what is the person or the location in a text, right? That is what we want to extract, or what is the gene name, like genomic data, that kind of thing. If you are dealing with genomic data, you are interested about what is the protein name, gene name, those kind of things, but you are not interested about all the other features. But maybe other features can be useful for your classification task, right? But you are not extracting that information. You are extracting the information that is specifically important for you, right? Meaningful information. On the other hand, feature extraction will extract any features that is helpful to make the classification better, for example, right? So that is the main difference. Okay. Now, let's see some of the ideas behind language model, right? So, as I said, we need to use GAN and then language model for better information extraction. The question is discriminator itself create a new data from the real data? Discriminator doesn't create the new data, right? As we saw, it tries to learn the boundary that separates different classes, like positive classes from the negative classes. So it learns only the boundary, that's it, right? It doesn't generate the data. On the other hand, the generative model tries to generate data, right? That are high probable. Generate data and then estimate the data probability, right? So that is the main difference. The discriminator doesn't generate data. It only learns the hyperplane that separate the data points. On the other hand, generative model generates the data. That is the main difference. When will again converts? Convergence you can test with several things. One is if you see that your discriminator loss and generator loss, they are not oscillating, like they have converged, then the GAN has converged. That is one sign. Another sign would be like you check some of your generated data for quality, see if they are good quality. That can be another thing, right? So yeah, those kind of things you can check. So the first check would be like checking if your generator loss and discriminator loss, if they are oscillating, that means they are not converged yet. But if they have become bit of stable, there will be small zigzag, that's fine. But overall it is stable, then you can say it is converged. Okay, so this one says some basic ideas behind language model, right? So in general, we can say a language model is a mechanism that can predict the next word given the previous words in a sequence, right? So a language model is all about sequential data or sequence. So not necessarily it would be words, it could be events. So if you have sequence of events, language model can predict the next event based on the previous events. So that is the main idea behind language model, right? So and then there were some like some like old how to say it, traditional ideas of language model. So there was this n-gram. So in the n-gram, given a sequence, people split it into say n number of items. So usually people run through a sliding window kind of thing and then find out which like, how to say, like which subset substring is frequent ones, right? So they use those as anagrams. The good side of anagram is that it is simple. You just run a sliding window. For example, the cat sat on the mat. You run a sliding window. The cat, you will get the cat sat on, right? This kind of anagrams. It is very straightforward. Um, and you can see if there is cat, there might be possibility that the next word would be set. If it is set, maybe next word is on, right? So it is very simple, straightforward. But the problem is, you can say it is limited by sliding window. If you so two problems here. If you use a small sliding window, you only capture small context like the cat, like two words only. On the other hand, if you want to increase your sliding window size, then it becomes very rare. Like finding out the probability of a very long anagram would be difficult. So this kind of models actually struggle to handle larger data set and then complex data set. So that is the problem. And so then next idea is Markov chain or Markov models. In the Markov model, they try to model the probability of a sequence from a sequence of events, right? So this is stochastic model. So it will predict the probability of a sequence of events. What is the probability that this sequence will happen, right? The cat sat. What is the probability that the cat sat on mat that will happen, right? So the good thing is it is flexible. It given any sequence, right, it can try to find out the probability of that. Now it is probabilistic and you have more flexibility, right? That is good thing. uh, and then that's why Markov models were very popular in earlier days. The problem is, okay, let me give a little bit more explanation. So here is an example, right? So it is similar to automata. So given a state, right, or an event, say it is a sunny day, what is the probability that next day will be sunny? So only 60% probability. And then the probability that next day will be cloudy is 30%. Right? And then if it is cloudy, the next day will be cloudy is 30%, and the next day will be sunny is 20%. So right, it can model this kind of probability. Through these Markov models, you can learn probability of different sequences. So that was good thing. But now the problem is because it depends on the previous word. It struggles to model the longer dependencies, right? So it only considered the previous one word, or in advanced ones maybe 2 or 3 words. So you can see that the model cannot capture the long-term dependency. For example, in a sentence, maybe the last word is depending on the what we said in the first word, right? Those can, and if it is a big sentence, or maybe in a paragraph, we say something in the beginning of the paragraph and then we refer that in the end of the paragraph. Or in a document, we start something in the first paragraph and then refer it again in the last paragraph. So those kind of long dependency cannot be modeled through Markov models. So that was the limitation. Then what happened is people started to model that long-term dependencies, right? So people started to use recurrent neural networks. The recurrent neural networks were more flexible. They could model long-term dependencies. But the problem was when they implemented, it was suffering from vanishing gradient, because it didn't have any mechanism to remember or forget, right? So it tried to propagate all the gradient through the long chain, and then because machine has precision problem, like if you have something in the fraction, right? So it has a precision, maybe 10 digits or 20 digits, right? After that, it starts forgetting things. So that is vanishing gradient problem. So now then people came up with the idea of long short-term memory, or LSTM, where they use a mechanism to decide what information to remember and what to forget. And that's how they could minimize that problem to some extent. But still, if the sequence is very long, still it struggles to handle that kind of thing. Another thing was because LSTM is also recurrent kind of model. So that means it needs to go through the whole sequence. If you have, say, 1000 words in a document, then it needs to do 1000 iteration to capture the information in that document, right? And that is very slow in terms of computation. Then people were struggling to how to solve that problem. Then in 2017, there was this idea of attention mechanism. There was a paper called "Attention is All You Need." In that attention mechanism, they showed that if you use the attention mechanism, then you can find out the relationship between all the possible terms, right? So long-term dependency you can learn, and also because it is parallelized. That means you don't need to go sequentially. You can see all the words at once. So, and then you can do the parallelization and everything. And so it became very fast to train this kind of models. And then after that, actually, we saw the revolution of AI in text domain. And there in 2018 came the BART, and then GPT, and various version of GPT, and then ChatGPT, and so on. So here in the diagram, you can see earlier in 2013, people started to use word-to-vec for learning n-gram kind of things. And then in 2014, there was people started to use RNN and LSTM in the text domain. And then 2016 and 17, they started to use transformer IDL, which is based on attention mechanism. And 2018, BART came. So then people started to use BART in all kinds of text domains. Then T5, GPT-3, and then PALM, and GPT-4, and so on. So in the transformer model, there were like we'll discuss more about encoder and decoder things. So BART used to use so BART is based on encoder technique, and where the GPT is based on decoder technique. Here you can see how the RNN and then the standard LSTM differ. The RNN has no mechanism to remember anything. So it just this models the next word based on previous words. That's it. But there is no mechanism to remember or forget. But in the LSTM, you have the mechanism to remember and forget. So that's how it was developed. Okay, so and you can see, and then the BART came, and the GPT, like a current tense is so, and the GPT there were many versions like GPT 2, 3, 4, and Omni, and so many, right? So there are many models there. Yep, and then currently people are trying to use multimodal models. So they try to combine text, image, and audio, and everything together, video as well, to develop much more diverse and more general version of language models. So you can see from very high level. So most of the language models today are based on transformers, or like attention mechanism. So you can see in the transformer, when the transformer came, it was based on actually the idea of translation. So you have a source language, say in English, I like science, and then you translate it into another language. I don't know which language it is. So if you translate it into another language, maybe Hindi or other language, right? So what it does so in the transformer, you have two blocks. One is encoder part. The encoder part will try to learn from the source language. I like science, so this source text. It will so it is defined in a way that it can represent this source information in a very effective way, right? So here the encoder part is designed to be more effective about how to represent something in the latent space, right? So this one is more of representation, or encoding, right, information in the latent space. And then in the decoder part, decoder will take the encoded information and then decode that into different language. So decode means actually it will generate the information, right? Uh, so there is one question that says, how do we decide the quality of the generator, right? Yesterday we talked about several mechanisms, how to decide the quality. Obviously, one is decoder deciding real or fake, but that is not all, you can see the difference between the generated data and the and the real data, the discrimination between generated data and the real data. And there were several measurement techniques how to decide the quality, right? So I think you can refer back to yesterday's presentation, and then there we discussed how to measure the quality of generated data. Okay, so this is like a transformer, right? Now you can see as we have two parts, and that is required for translation, because you have two things. One is like learning, representing the source, and then another is generating the target language, right? That's why you need two mechanisms. But now in some areas, you may not need both of them. So for example, in classification, you just need a mechanism that can represent the data into the latent space. That's all. And after the representation, you can use an additional layer that will just take that information and classify into different classes. So in that case, you use the encoder part. So this is the encoder part. So for classification kind of things, it is more effective to use encoder part. So you represent that information into the latent space and then do the classification. On the other hand, if you want to generate information like ChatGPT kind of things, where you generate new information or abstract or like information in a way, like you understand the question or that context, and based on that you generate the answer, right? Instead of extracting information, you generate the information. If that is the case, then you use the decoder part of the model that is designed to generate information, right? So you can use that part. So that's why you can see BART and those kind of models, they are actually encoder models based on encoder, and they are mostly used for classification purpose. On the other hand, GPT models, they are generative models. They generate information. That's why you see them being used for ChatGPT uh, and Being and those kind of like models where you generate the information. The idea behind the encoder and decoder is that you can see in the encoder, you use self-attention. That means this is the orange ones. This is the whole sequence, whole input sequence. So your attention will see all of them, and based on that it will generate the attention, right? Attention score. So it will see the whole sequence together, and then based on that it will generate it will like give you or represent it to the encoder sorry, attention score, right? Give you the attention score. On the other hand, the decoder is based on mask self-attention. So mask self-attention means it will mask out the future tokens. So for example, given this orange ones, you want to predict these gray ones, right? So if you want to do that, the encoder will not encoder, the attention will see only the these orange ones, and based on that it will generate the attention score, and you will and your model will use that attention score to make the prediction about these gray ones, like future tokens, right? So that is the main difference. It uses a masking mechanism to prevent the model seeing the future tokens. So that's how it can generate new information. In a more elaborate way, here you can see in encoder model, you encode, and then when you generate the latent space based on your attention score, you can see each token or each layer, each hidden state can see all the tokens, right? All of them. There is no prevention of seeing anything. On the other hand, if it is decoder transformer, you can see first token can see only the first token. The like first hidden state can see only the first token. Second hidden state can see the first one and the second one. It cannot see the third one. On the other hand, third hidden state can see the first, second, and third, right? So that's how it works. The main difference between them. Now let's see what happened to the language model, right? Um, so in the language model, you can see the basic definition is that given a sequence of event or words, you try to predict the next word or next event, right? That is the definition. And then you can do it through a very basic models, for example, RNN, LSTM, Markov models, and so on, right? Those are basic models and simple models. The problem with those models is you cannot scale them for large amount of data, big amount of data, right? So to scale them with big amount of data, the people started to use transformers, and because of transformer, they can train the model with like trillions of data points, right? So that's how people started to use bigger and bigger models, right? So you can see after transformer, people came up with GPT with 340 million parameters, and sorry, BART model was 3.40 million data points, 340 million. And then GPT-2, it had 1.5 billion data points, parameters. And then you can see when people got to GPT-3, there was 175 billion parameters. And then if you see the current one, there are 1 trillion parameters, right? So exponentially, the model size is increasing, and because the model size is exponentially bigger, they can train the model with exponentially bigger size of data. And then these kind of models can learn from vast amount of data and then do magical things. That's why you see ChatGPT so interesting, so accurate to generate the text. So you can see this kind of models that have bigger size, we call them large language model, right? Um, because they are large in size and trained with larger size of data. That's why we call them large language model. But the technique is just language model idea, right? It is just bigger in size. That's why large language model. So we saw that language models are used in different areas, and specifically for information extraction, it is predominantly used in healthcare for extracting and summarizing patient information. In finance, it is used to analyze the financial report and news articles to make better decision. And in legal, then it try to learn the relevant information from legal documents for analyzing different cases, right? So you can give many examples of how information extraction is helping different industries and applications. So here we are showing an example of how you can use a large language model like ChatGPT to extract information, right? Or get the answer to your questions, right? So for example, you give it some information, and then here, if you can read it, zooming in. If each storybook is $20, I have $50. How much I need to save to buy these books? So you have given the context that you have $50, and then each of the storybook cost you $20, right? And then you ask to extract an information, right? So that this is extracted information needs to understand this, what information you have and how to reason about that to give the answer, right? So you can see if you ask this one to ChatGPT, it will go step by step to get the answer. And it says to buy 3 books, you need to multiply the price of book by 3. So book price is 20 and multiply it by 3, that means $60. So you need $60. And then it says you already have $50. So you subtract $50 from 60, and that gives you 10. That means you will need another $10 to buy books, right? So you can see how this kind of models can give you a very nice answer, and how they can make a reasoning about complex problems. You can ask it to generate a Python code, right? And it will generate Python code, explain the code, and then give you the answer. Or you can ask it to generate pictures, right? Images. I asked, can you draw a picture of Thor, the character in Marvel movie, that he's teaching generative AI, and you can see it generated 4 pictures, right? It was through DALL-E 3. Okay, now I can actually show you. Okay, not this one. Okay, yep. Now, if you what is the time? 45. Okay, so it has been more than 1 hour. I think we can take a 10 minutes break. Is it a good idea? So I can see there is one question. Yeah, so there is one question about can we use GAN for building question answer system? Yes, we can do that, and we will do that. We'll show you today how to do that. Thank you. So we'll come back at after 10 minutes. It is 46. So we'll come at like 56. We'll come back at 56. Thank you. So to do this, I think I need to stop sharing. Okay, hello everyone. Let's start again. Can you hear me now? Okay, thank you. So now for the large language models, there are some observations you can see because large language models are generated to be general purpose. So if someone is general purpose, obviously they may not be that much accurate for specialized areas. So that is happening in large language model, because these kind of models, they can do everything, but if you check or check their accuracy against any specialized area, then you will see that their accuracy is not great. But overall it is diverse, and then it can give you very nice answer for many various application areas, right? But when you go for a specific area, then you will see there are some problems, right? The reason is that if you have a task agnostic model, uh, it's me. Yeah, yeah. See, so if you say, if you train a task agnostic model, you have a big model, and then it covers a large domain area, right? But the problem is the specialized task maybe that relies in that in this area, right? Task is specific, the specialized area, and then you can see there is very small common, maybe a specialized area needs a specialized treatment on things, and then out of that maybe a small portion of data you labeled, right? So that's why when you use the general purpose model for a specialized area, you will get maybe incorrect answer. So if you take the like general purpose train model and do a little bit of fine tuning to the specialized area, and then you will see you get much better accurate answer. Now this so today we are going to use, as I said, large language model and then generative AI in GAN setting for information extraction. Towards that, we will start with large language model, right? How we can use language model and large language model for information extraction. So the motivation here is that if you have a traditional information extraction system, then to analyze for some spatial purpose to make a decision, you may need to go to your emails and extract some of the information from the emails, some information from social media, some from your relational database, some documents, your chat history, and so on. So for each of them, you need a specialized program and write query about for extracting information from that, and then again you need a mechanism to analyze all this information, and then finally you come to a conclusion, right? So that is like more very complex and not that general purpose, right? Very complex and time consuming process. On the other hand, in large language model, the vision is that you have a large language model and then the large language model, because it can understand structured and unstructured data, it can read through all the emails, social media, your relational database, and so on. It can read all those things and then analyze the information there, and then finally it can give you the answer for your specific question. So that can make the life easy, and then the decision making becomes much faster and general purpose. So here is an example. If you want to use a large language model for information extraction or like question answer purpose, but like generally you can think it as a question answer system, right? But you trick the model a little bit so that it becomes information extraction instead of like a question answer system, right? So how do you do that? You give specific instruction to the model. So for example, here I'm showing an example through ChatGPT, right? So here you give an initial prompt where you specify how the model should respond or pretend a specific characteristics, right? So you say, assume that you are a geologist, you know the information about Queensland minerals and energy resources and blah blah things, right? So you say that this is the role that you will play, and then you give a context. That means you document or paragraphs, right? You give the document here called context. So you give that information where it says about something related to what is this, well purpose, right? Something like that. And then you want to extract information about well purpose, right? And then so you need to explain what is a well purpose. You say well purpose is the primary intended function at the time of drilling of the well, right? So you define what is well purpose. Otherwise it will assume based on its own knowledge. Then the answer might be correct or incorrect, you don't know. So if you give the explanation what is well purpose, then it knows, okay, that is the thing that we are looking for. Then you ask the question. You say, can you extract the well purpose from the context? So you want to extract that is specific information related to well purpose. And then ChatGPT says the well purpose is the primary intended function at the time of drilling of the well. So it explains what it understood about the well purpose, and then says based on the text context, that means the text we gave, it says I can extract the well purpose as follows: to produce gas from the Ulun coal seams in the Combebula field, right? So that is the extracted information we are looking for. So this part, right? It gives that information in this third bracket, right? So this is the extracted information. And then further, you can ask it to explain where it found the information. It says, then it says, I found the information in the first sentence of text context, right? So in the text context, first sentence, it says here, right? To produce gas, see, to produce gas from Wollongong in the build up. See, in the first sentence, the information is there. That's why it says, I found the information in the first sentence of the text context, where it says, so it explains, and then it says how it found the information, right? So now you can see it is very nice. It gives an interactive way of information extraction. You can ask it to extract the information. You can ask it to explain, right? And then you can get the information. Voice is not clear. In terms of voice, I'm using the same settings, everything same. I'm not sure. Can other people hear me clearly? Okay, looks like, yeah, other people are seeing it clearly. So I assume that maybe you're at your end, maybe it was not clear. Okay, thank you. Yeah, right. So now you can say that is very nice and very user-friendly way to extract information. You can get explanation and so on, right? It is very like very nice thing that you can have. The problem would be, all right, sometimes it will hallucinate, and sometimes the information it gives may not be correct, right? That would be the problem. So we'll need mechanism to solve that problem. So what is the time? Okay, so now that this is your generative model, right? Because it is ChatGPT, it is a generative model. It uses decoder only model. That means the idea is mask self attention. So based on that, it is generating the information. The problem is because it is general purpose, and then in other words, it is not fine-tuned for a specific domain. More specifically, it is not fine-tuned for this data set that Department of Resources at Queensland. So that's why the information that you get may not be accurate always. Right? Sometimes you will get incorrect information. But we know that if it is if it is encoder based model, then it can learn the classification more accurately, right? So now we'll try to use the encoder part of the transformer to see if we can improve the situation in a way. So in the so one example of encoder only model is BART, right? So you all know that you can have a BART model, and then you can use that BART model to do your classification task. Now, if you if you tweak your question uh, of information extraction, then you can actually use the BART model, similar fashion of classification to extract information, right? How can you do that? The idea is here. So you have a question, right? And then in the BART model, if you checked it earlier, you know that in BART model you have two parts. So it starts with a token called CLS, which is like classification part, and then it takes one sentence or one like segment of text, and then it uses a separator called SCP, this token, and then it takes another segment of text, right? So this part in the BART context, it was used to see two sentences are similar or not during the training process, right? So now if you change a little bit, in the first part you send your question, right? The first text segment as question, and the second text segment you send your context or reference text, right? You send that one. And then you can ask the model, instead of classification, you can ask the model, can you predict the start position? So one output will give you the start position, right? Location of start position of the answer. And then another output will give you the end position of the answer. Right? So if you know the start and end position of the answer in your context, right? Say here, this part may be, this part is answered, then that start and end position you can utilize to extract your information. So that's how we use BART kind of model for extractive question answer system. Now the question is not generated, it is extracted. That means no new information, no change, and nothing. It will just tell you the beginning and end of the answer in the context. So this kind of models advantage is because it is encoder kind of model. It can more effectively encode your context and question, and because it is not generating, so you don't need to like learn the complex joint probability distribution. Rather, you can use the conditional probability distribution to get the starting and end position, right? So usually this kind of models, and also because this kind of model you can easily fine tune to your specific domain. That's why this kind of models will give you quite better accuracy compared with your generative model, right? Now, you can see the generative model gives you the flexibility and then very nice user-friendly environment. And then if you have a this BERT kind of discriminative model that can extract the information, and then based on these two, actually, you can check and balance between the generated answer and then the extracted information, right? So if they say, okay, both of them are similar or same, then you can assume that whatever the generator is generating, it is good one. But if they differentiate, then you can have another mechanism to correct them, right? So that's how, by doing these two different phenomena of transformer model, we can get a better model that can give you better information extraction. So that is what we actually did case study with Department of Resources at Queensland University, at Queensland. We will see that in the coding part. Right. So what is the time? Okay, 15. So I will explain a little bit here, and then yeah, let me see. Yeah. So to do the case study, we have actually two case study. One is through large language model, and the case study is based on GAN. So yeah, I think GAN part we will explain during our the like hands-on session. So we'll end this part of the module at I think in Indian time it is 11 o'clock, and then we will resume at 12 o'clock Indian time. In Brisbane time, I will end this part at 3:30 and then resume at 4:30. Yeah. So yeah, so this part I will explain now, and then the next part we will explain during the hands-on, because you already have some idea of how GAN works and things that we discussed yesterday. Okay, now this data set, like we collected data, like we collected 13,184 well or petroleum reports, like well and petroleum reports. They are coming from Department of Resources. And then out of these, we took 1,160 reports. They are very long reports, and they were manually annotated for question answer system. Like we have various questions and their answers for that these 1,160 documents, right? So how did we do the annotation? Because they are long documents, we split it in them into smaller chunks, and then we annotated those smaller chunks. And then out of those annotation, we use 80% data for training and validation, and then 20% data for the testing, right? And then so out of this thing, we had 80,000 question answer pairs. So out of these 1,160 documents, we had 80,000 question answer pairs. Like we had several questions and answer for them, right? And then you can say out of 20 we question answer pairs for training, and then 20,000 question answer pairs for testing. The questions were related to well name, operator, lease name, lease number, current class, well purpose, surface latitude, surface longitude, ground elevation, and so on, right? So here is the definition and some examples how the answer should look like. And then there is the documents are coming from 1960s up until 2020. So all the documents here, and then you can see the distribution over the time, the proportion that coming from different years. And then how does it look like the one segment? So this is one example how it looks like. You have the ID. So ID is like the ID of the document, so that after question answer we can reconstruct the document and then publish our question answer or extracted information, right? And we have the title of the document. So these are like information management. For information management, these two doesn't they do not go to the model. They are just for management purpose. And then you have the context, right? Context is a text segment, and then you have question and then the answer, right? The question is well name, and the text is the well name is rum bottle. Answer it starts at 44. Okay, so this is character level position 44 and ends at 55. Right? So that is the answer starts and ends. So this is the format that we utilized for training the question answer system. Okay, so one question is why 80-20, why not cross validation? So this 80-20 is for training and testing. So from the beginning, we separate out 20% of data that we do not use during the training, right? The model will never see that 20% data. So that is completely separated out. And then out of the 80% data, we used cross validation for training and validation. So after training and validation, everything is done. Then we test on the 20% data to report the accuracy of the model. So that's how usually we do it. But for 20%, that is not necessarily you need to be 20%. That could be 30%. That could be any other proportion. It depends on your data set, your application, and so on. Yeah. Another question is if we are modeling data manually, modifying data manually, then I think we are not leveraging LLM fully. Modifying. So we when you say modifying data manually, I'm not sure what you're referring, but the idea is you train the large language model here, the BART pre-trained model. So it is pre-trained, fully pre-trained on large amount of data. So that learns only the general data distribution from general domain, right? That could be related to novel, that could be related to chemistry, that could be related to movies and so on, right? Then we fine tune that pre-trained model to the specific domain of coals and minerals related geological data, right? Now the model becomes more specific towards that domain. So that's how we are doing. So in other words, we are utilizing the large language model, but we are doing fine tuning over that helps the model to be more knowledgeable about the specific domain. Okay, so this part you can see this is the proprietary data. I will show you how to run it on that thing, everything. But the problem is I cannot release this data. This data actually belongs to Department of Resources at Queensland. So that's why, and that's why I cannot release the data. But I will show you how to run the same model utilizing open data source like the Squad data set. Right, so Squad is openly available, so you can use the Squad data set to train the model and see accuracy. Right, we'll do these two things, and then yeah. So let me give a little bit of overview how what is the Squad dataset if you don't know it already. So the Squad dataset, it comes with a large collection of question answer pair. You can see you have 100,000 question answer pairs, and then they are coming from 536 Wikipedia articles, right? And then they are claiming they are diversely distributed. Uh, so you don't need actually the DOR dataset that is proprietary, but you will have the same thing through this open source and the Squad dataset. I am told that I cannot share the data even on the canvas. That is like restricted because of copyright and other legal things. I cannot give the Squad. I cannot give you the DOR data, like geological data, but you will have the pretty much similar things if you use the Squad dataset. Okay, during the hands-on part, we will show you where to get the Squad data and then train it, right? Everything will show you. So don't need to worry about the Squad data. The Squad data actually, you can download it through the source, but it is available through Transformer. If you are using Hugging Face, so it is available through Hugging Face. So we will use a function that will easily download the data from Hugging Face and then train the model. So that will be pretty much a piece of cake, right? It should be easy. So far, do you have any questions related to anything that we discussed so far? we have 6 minutes. I will try to answer some of your questions that related to this part, and then we will have a break for 1 hour. You will come back at 12 noon Indian time. We will start hands-on part where I will explain how to implement this model, and then like also the another explain about the other part of the model. So in the next part, I will actually start with the explanation of using GAN for information extraction, right? And then yeah, and then we'll implement the model. Want to know how long it takes to prepare question answer data format as input? How so when you say how long it takes to prepare, do you mean data collection part, or the model takes time to load it? I think you're referring data collection. So data collection part, uh, yeah. So data collection part, I am not very sure actually. For Department of Resources, they had their own engineers, and then they had a team who did the annotation. I'm not very sure, right? um, but I saw that like they had like a team when I was training this model. They had a team who did the data collection and annotation. So there was one question about yesterday, like code. Okay, I will check the canvas. But if it is related to the thing that it says part of the data is on CPU, part of data on GPU, then that part I checked this morning, and it was coming from the version change. So I fixed part of it. I'll show you how to fix it, and yeah, we'll discuss that part. For the data training purpose, we needed the annotated data, because if you do not fine-tune your model through this specific annotated data, then the model accuracy was not very good. So we had to fine-tune the model through annotated data from the Department of Resources. That helped us to get better accuracy. How to evaluate the question answer system? Yes, I will show you. There will be several things. Some will be precision recall F1 score. Also, there is this thing called how much it matches. Like, does it 100% matches, or there is some variations? It is 50% matches, and other things you can consider as well. Yeah. Okay, so now okay. Okay. Yeah. Yep. What is the time remaining? 27. Okay, now I think all these questions we can maybe finish this slide only. Then some of your questions would be more clear. So, for example, here I show you the experimental results that we got from this case study, right? So we did the experiments with ChatGPT. We call it ChatGPT QAM, and then you can see the F1 score is around 60%, right? 59, around 60%. But if you do the same thing, like the question information extraction through this fine-tuned model through BART, that we call BART QAM, you can see the accuracy is much better. The F1 score is 75. So that's why you need to fine-tune your model for the specific domain. We try to use general purpose BART name entity recognition system, but that was not very good. The accuracy was around only 40%, right? The F1 score is only 40%, so that was not very good as well. We did test it with for the squad data set as well. You can see if you use the BERT question answer system, like fine-tuned one, the accuracy is again 76%. On the other hand, if you use ChatGPT, and then your accuracy is around 62%, right? So you can see why you need to fine tune your model to the specific domain. That means you need to, if you need to get high accuracy, you will need to fine tune your model. And then to give the other part of the answer to the other question that says how to measure the accuracy. So you can see we are using uh, recall, precision, and F1 score, right? And we also do some measure called exact match. That means you generated answer and the ground truth, they exactly matches. If that is the case, we call exact match. Otherwise, it is partial match, partially matches, right? And then how does the partial matching look like? So you can see here, your ground truth is Fairview, and then your predicted answer is Fairview 271. See, sometimes it can give you extra information that you don't need. So that means it is partially matching. The second one, you can see Bandemar 1. On the other hand, you can see Bandemar 1 is there, but it gives you extra information, right? So this extra information, that means it is partially matching. Or here, MU nest 1, but it gives you only M, like only part of the answer. Or here, Arcadia branch 2, it gives you answer as Arcadia only. So if this is the case, it is partially matching. On the other hand, if the answer is exactly matching the ground truth, we call it exactly matching. What is it? How? GAN and RAG, which one will be the better for question answer system? Usually, if it is domain specific question answer, people commonly uses RAG. But because RAG is almost coming like freely available, you can think of it much easy to train, and you don't need much like training data or anything, right? So you just need to know how to get the relevant information. That's it, relevant documents, and then from that one you can ask the GPT to generate the answer. So RAG is very common, yes, easy to implement. But if you want accuracy even better than RAG, you can use the fine-tuned model. To get about the GAN, we'll show and explain how GAN to be used and what is the advantage and limitation of GANs. The advantage is, yeah, I will explain those things in the answer part, and then that will make more sense. So it is 11 o'clock Indian time. We can have a break now for 1 hour and then come back at 12 noon. And then so when you come back, we will discuss about how to use like GAN model for information extraction, and then we will try to see, we'll do the coding for information extraction through a language model. And we'll try to give so this time actually I will try to run the code for with CPU and GPU both to see if there is any problem that we will see. And then for that yesterday's part, as I said, the problem was coming from version differences. So yeah, it was running perfectly on CPU, but when I was running on GPU, there was some problem. I saw that like my older GPU, like older installation or older machine, it is working, but then I installed a fresh copy on different machine, and it looks like because of version change, there was some problem, and then I fixed. Is we don't have a quiz today. You will have the quiz next week. This is one thing. So the next quiz will be based on whatever you learned yesterday and you're learning today, based on this tomorrow. Yeah, thank you.